Hi, this is Jessica Williman, and I'm here to talk to you about my research project titled The Practice Effect on the Stroop Task. My research question was, will people improve their response times when they do their Stroop task more than once? I hypothesized that the response times for the Stroop task will decrease when participants do the Stroop task more than once. Douglas J. Davidson, Rose T. Zaks, and Carrick C. Williams in 2003 studied the practice effect on the Stroop color word interference task in both older and younger adults. They ran two experiments. In experiment 1, there was a between subject design in which there was a Stroop condition and a practice block, which was a within subject's design. There were interference trials in which the color to be named was different from the color word. There was also a control trial. In both trials, there were 192 trials for the first experiment. In the second experiment, the conditions were all the same except that they added a facilitation condition in a total of 1,536 trials. As you can see from the results, with practice, the Stroop effect can be conquered for both younger and older adults. Older adults were slower to respond in the interference trials. In both age groups, though, their response times were faster for the practice trials. With reference to how their study fits in with my hypothesis, their study demonstrates that practice does improve response times in the Stroop task. What I want to be understood is that this study shows that practice works. A study by Penny Dodds, Christopher Donkin, Scott D. Brown, and Andrew Heathcote in 2011 tried to answer the question, can undimensional stimuli in the absolute identification task prevent one from being able to memorize for more than just the 7 plus or minus 2 capacity for short-term memory? The series of experiments presented in this study was also aiming to understand how practice improves performance of such activities. 7 experiments were conducted. The first experiment was split into 2, Experiment 1A and 1B, in which 6 participants took part in. The aim was to test whether atypical design features would cause a larger learning effect. For Experiment 1A, the researchers also gave the participants 2 chances to respond. So if they incorrectly responded the first time, they would get another chance to get it right. For Experiment 1B, this was not the case. The stimuli used were 30 lines of different sized black lines on a white background in the middle of a computer screen. They were given a study phase in which they were given a stimuli and they were to press a numbered button that corresponded to the line that was given. Then the participants proceeded to the trial part of the experiment in which they were to select the correct number button that corresponded to the line. Experiment 2 was conducted in the dark and was also split into 2 sections as well. The response buttons were also not on the screen at the time of the stimulus to test whether the response was due to the information being available on the screen at the time that the participant responded. But in Experiment 2B, only half of the stimulus was on the screen at the same time the participants were responding. Instead of lines, a pair of white dots on a black background were separated by the same lengths as the lines in the previous experiments. In Experiment 2A, there were 30 stimuli. In Experiment 2B, there were 15 stimuli. In Experiment 3, the lines and pairs of dots that were used were only presented for 1 second. In Experiment 4, the lines were presented in angles. In Experiment 5, the researchers were testing the practice effects of seeing the lines versus hearing a tone of different frequencies. In Experiment 6, participants were presented with tones of varying intensities. In Experiment 7, the researchers manipulated the participants' motivation by giving them money for accuracy of their responses. Here you can see the results for each of these experiments. Each experiment was reported in terms of accuracy and transferring of information. In simple terms, the results show that in Experiment 1, practice did seem to show improved performance, which also indicates that the participants' opportunity of getting a second chance to respond correctly did not play a factor in the correct responses. In Experiment 2, improvements in performance was shown, and this finding also shows that external cues and amount of available information does not play a factor in learning. In Experiment 3, the results show that practice improves performance even if there is limited stimulus presentation times. In Experiment 4, the the results indicate that improvement in performance occurred and that the learning effect extends to stimuli that are not lines. In experiment 5, the participants who practiced with lines showed improvements, but those practicing with tones did not show improvements. In experiment 6, the results indicate that the participants did a little better than the participants in experiment 5b, but not by much when compared to the performance of those who were in the visualized stimuli condition. In experiment 7, it appears that participants who received money for accuracy did twice as well in learning compared to people who received money whether they performed well or not. Again, these results further confirm my hypothesis that practice improves response times, and how this study fits in with the first study. It shows that also the benefit of practice. A study done by Dietsje D. Jolis, Mickey J. Grohl, Mark A. Van Buchen, Sergey A.R.B. Rombouts, and Evelyn A. Krohn in 2011 was attempting to understand how practice affected different types of working memory tasks. They were also interested in comparing the effects of practice that went on for a time due to familiarity. To do this, the researchers took 29 participants and separated them into two groups, a control group and a practice group. The practice group and the control group took two tests and were put into two time points. The practice point was put into time point 1, and the control group was part of time point 2. In time point 1, the practice participants did a series of tasks that were to be practiced over a 6-week period. Once a week they practiced while supervised, and the rest of the week they practiced on their own. When it came time for time point 2, the participants performed a series of tasks compared to compare success rates of the practice group to the control group. 6 months after that, they took part in a follow-up verbal working memory task. Their brain scans were also scanned using MRI. Here the results are shown. After 6 weeks of continued practice, the participants showed improvements on the task, and also their brain scans indicated that neural activity changed. Again, the results relate to the study 1 and 2 by showing that practice does indeed work. Another important thing to keep in mind is the fact that not only does practice improve response times, but it can also affect the way the brain is activated, such as becoming activated in the frontoparietal network. In my study, the participants involved included 9 students from an intermediate statistics and research methods class and 1 faculty member from Central Washington University at the Des Moines campus. The design used was a one-group test-retest within subject design. The independent variable was the repeated exposure to the Stroop task. The dependent variable was the response times. The results were measured on a ratio scale. The materials that were used was a Nintendo DS and a game called Brain Age. Brain Age has an exercise called the Stroop task. There was only 1 device in possession, so the participants had to use the device one at a time. Each participant, one after another, completed the Stroop task exercise in the Brain Age game using the Nintendo DS. They were to speak aloud the color of the color word. So, for example, if the word was red and the color blue, the correct response would be blue. In order to move on to the next word, it was necessary that the response be correct. Each participant did the Stroop task twice, with each response time being recorded. To interpret the results, the response times were converted into seconds, and a test-retest t-test was ran. As you can see, the results were not statistically significant. Between the first time and the second time, the mean was 14.90, and the standard deviation was 28.3016. To interpret the results, the response times were converted into seconds, and a test-retest t-test was ran. As you can see, the results were not statistically significant. Between the first time and the second time, the mean was 14.90, and the standard deviation was 28.3016. In this slide, I present the data table showing you everything I've just said and more. Here I have created a bar graph to illustrate the data from each of the participants. As you can see, all but 2 participants, participants 2 and 7, had a decreased response time the second time around. So what do the results mean? The statistical data indicates that there was not enough improvement to be considered significant, but this could be due to the fact that there were only 10 participants in the study, and the Stroop task was only done twice. Perhaps if there were, say, 30 participants and they were doing the Stroop task 20 times, the result may actually show more promising results. Another thing to consider was the fact that there were some technical problems with the game's device built-in microphone, as it would not pick up a participant's voice at times, and this played a factor in the ending results. Still, the fact that most of the response times decreased the second time around reiterates the points I've been trying to stress all along. Practice does lead to improvement. In the future, if this study were to be picked up again, it would be a benefit of the study to use a different technology to test the Stroop task and more people to show significant test results. Here are the references that I have used for this presentation. Thank you for listening. Does anybody have any questions?